Hello, everyone. Thank you for joining today's webinar. This is Nick Palmer from Group IB. We're just going to give everyone a couple of minutes to continue to join. We have a good number of attendees on the line, but we'll just wait a couple more minutes as we have some others joining. All right, everyone, good morning. And again, thank you very much for joining today's webinar, How to Choose a Sandbox, Do's and Don'ts. My name is Nicholas Palmer. I'm the Director of International Business Development at Group IB. And I'm also joined by one of the creators of our network security appliance called TDS and our sandbox called Polygon, Nikita Kislitsin. Nikita. Hey. All right, so thank you again, everyone, for joining us. So let's get started. Of course, just to remind everyone that we will be providing the recording and the slides if you would like them, and we'll send them out in the next couple of days after the webinar. The webinar is being recorded, so we'll also send out a recording of such. And everyone is on mute, but if you have questions, we would be happy to address them in the question panel for GoToMeeting. So if no one knows about Group IB, we'll just kind of give a 20-second introduction to who we are and what we do. Group IB is a threat intelligence, anti-fraud, and network security vendor, and we have been operating within the high-tech security space for the last 15 years. We work very closely with Europol and Interpol. We've signed MOUs with both these organizations to provide them knowledge of different cyber crimes and different actors that conduct them in hopes that some arrests are made. And if you're interested to read more about our threat intelligence, anti-fraud, or network security appliances, you can do so in researches like Forrester, Gartner, and IDC. So that's just a brief introduction. Now let's jump right into the meat of today's webinar. And what we're going to cover in today's webinar is different terminology connected to Sandbox, some of the different common mistakes that are used when evaluating different sandboxes in POC phases, different testing vectors that you can use, importantly, how you can actually compare the different sandboxes, and talk about some of the different best practices as well. So first, just some of the terminology connected to Sandbox. Obviously, Sandbox is a security mechanism that really allows you to perform dynamic analysis of files and different links, but in an isolated environment to determine if they're malicious and understand how they behave in some way, if they're malicious or not. We'll cover sandboxes that protect mainly legitimate flows like email, web traffic, and files for document flow systems in shared resources. Some of the different use cases that were directed at different sandboxes is really to improve email security. You know, a lot of the different initial infection vectors with different targeted attacks is spear phishing emails. I think that's pretty status quo with a lot of targeted attack groups. So using a sandbox can really block malicious messages, malicious content overlooked by traditional security tools. The second use case for Sandbox is to analyze web traffic. So scanning downloaded files and detecting these malicious files and potentially targeted attacks that are detected within the network. Also blocking downloads of malicious content that potentially would be exploited within the network. The third use case is to analyze potentially dangerous objects in custom systems. You know, look at document flows, identify suspicious content from different users. The fourth use case is to use it as an internal tool to analyze incidents. To manually download suspicious files, analyze them, and understand if the verdict is either positive or negative in terms of it being malicious. So using it as an internal tool to analyze different incidents. And I'll actually now hand it over to Sergey. Excuse me, it's early still here in Moscow. Hand it over to Nikita to go over some of the different test cases.
Yeah. Hello, everyone. Again, my name is Nikita Kislitsyn, and I lead development of the product, TDS and Polygon. So today we'll go through general testing approaches that could be used to verify that a specific product actually does what it's written in its white paper, and also we'll see what actually may differentiate different products in some cases. So I will also try to give you very practical thoughts on how you could actually perform such testing activities in your company. If you evaluate such products, it will be helpful, I believe. So the main idea is, and the main question you should answer yourself before starting testing any sandbox is basically what the goal you expect to be achieved. What is your main goal here? So in case, for instance, you want to improve email security. That means that you need to address in your test cases to actual threats that are distributed through this vector, and in your test cases they should be selected in a specific way which reflects the actual landscape of the threats. So and another important point is that your expectations about testing should be realistic. Any sandbox is just a tool that increases security, and sometimes sandboxes are very complex systems, very difficult ones, but nothing is perfect here. I mean, no, there is no solution that guarantees 100% detection rate, and so expectations should be realistic in these terms. You should really understand that okay, I want to increase security of my email protection system. Now it's not perfect because antiviruses misses lots of threats, and now I want to deploy a new solution that will block these threats after AV failed to do this. So now I'll go through very common mistakes we actually meet while evaluating our product with clients and on the market. In many cases, we meet situations when customers actually try to evaluate a system and compare to different solutions between each other. So I'll just go through the common mistakes that are not actually testing anything or are not reflecting actual problem. So the main problem and the main common mistake is tests that are based on dead files. So usually it starts like someone has a set of malicious files that he has been collecting like last 10 years, or such files were downloaded by him from like some open source website, from VirusTotal, for instance. And this person just takes these files and emails them to his own mailbox and sees what will happen next. Thing is that if the files are old enough and they are basically dead in terms of its original malicious functionality, and by the death I mean all the situations when command control servers are blocked, payloads are not available anymore by the links that were used in the attack. All these situations, they're crucial for the malicious functionality to actually work. And what sandboxes do, they detect malicious behavior. That's basically what they are designed for. So when anybody takes old files 10 years ago made, or even 6 months ago made, and tries to analyze them in Sandbox, he actually risks to face the situation when the malicious file is not malicious anymore by its behavior. So, and in this case, the test degrades itself to just testing a built-in antivirus that is deployed within that specific sandbox. So, and it wasn't probably the original idea, right? We wanted to increase security and check whether specific sandbox could actually block something antiviruses couldn't find. And now we test the sandbox with old files that are not doing anything wrong on the system because they're not working anymore. And in these cases, what is actually tested, a built-in antivirus, which wasn't our goal at all. And from this test, from my point of view, we couldn't conclude anything. If the sandbox detected 100% of malicious files, no, it's still not a good sandbox. It just has an antivirus inside of it. It works well, but all the detects are based on antivirus technology, and it's not what you want to pay buying Sandbox, not at all. So another situation when Sandbox didn't detect even half of the malicious files. No, this Sandbox isn't bad or good in this case. It's okay from my point of view again. Because the main goal that Sandbox has to actually deliver is dynamic analysis. And if the file isn't functionable anymore, the dynamic analysis couldn't be done. So the test itself is quite bad for this goal. Okay. Similar situation, but in this case, files are originating from some open source, like VirusTotal, for instance. So files might be very fresh and they could be uploaded to antivirus like yesterday, but still, if the end user performing the test just randomly download these malicious files that have high ranks on VirusTotal, again, there might be lots of problem. For instance, many files uploaded to VirusTotal are not something really malicious in terms of Windows workstations, right? If you upload a PHP web shell designed to attack web resources, it will have a high rank on VirusTotal. Lots of antivirus will say that, okay, it's kind of backdoor file. But if you couldn't even launch it and execute it on a Windows machine, right? So if you will email this file to all your company, nothing will happen. I mean, no one will actually get infected from this. So, and it's just bad idea to expect that Sandbox should detect such PHP scripts that are just has no connection to the main idea. So, and of course, this is very, like, I'm a bit of exaggerating the problem, but there are lots of technical things that could interfere the test. If you pick up files from open sources, you really should understand what you're doing, and you really need to understand at least what formats you actually download and include in your test set. For instance, if you put the DLL files or settings files from Trojans, these objects, they are usually not malicious by themselves. They are just a part of a bigger malicious system. So when you separately upload a DLL file, it's a library file, right? So yes, there are some functionalities implemented, but it couldn't, in many cases, it couldn't even be launched without other parts of the system. So again, it's not a good idea to expect that Sandbox really has to detect such objects. It has nothing to do with this. Again, in these cases, the test degrades itself to just testing built-in antivirus, which wasn't our goal at this point. Another problem is, and we actually quite oftenly face it, unsupervised test. So the problem here is that the guy performing the test not actually understand how everything is working on his system. For instance, on email, he just picks up files, send these files to his own mailbox, and expect that this installed Sandbox has to detect them. But he doesn't think about that simple fact that email system has already has lots of products to protect mail flow, right? Starting from anti-spam solution to AV solution, and he sends like 10 letters and see that only 3 of them actually alerted on a Sandbox, and he say, okay, only 30% of my test cases were detected by your Sandbox. And this conclusion is wrong, because 7 of the original letters were just blocked on either antivirus or anti-spam solution installed before Sandbox. So all the tests unnecessarily need to be supervised thoroughly, and every step in the test has to be under control in order to have good conclusions from that test. Another interesting common problem, we actually twice faced it in different clients while evaluating our product. Originally people just wanted to change a little bit files, malicious ones, so the hash of the file would change. For instance, they had like PDF file malicious, and they realized that it is detectable just by its own hash, MD5 or for instance. And they say, okay, I see all the solutions detected by reputation. It's not what I wanted, actually. I wanted to, so it could be detected by behavior. It would run in Sandbox and so on. And what they did, they actually modified the files incorrectly. For instance, they could put random bytes to the end of the file format. And many file formats, they will be corrupted after that. And they couldn't be open anymore after this And again, no actual dynamic analysis could happen after you corrupt the original file. That's the problem. I wasn't expecting, even thinking of it, but it's actually happening, and people really do this. So it's a common mistake which I wanted to notice and highlight. Another general problem is that many clients, not the clients, but the engineers involved in the test, they just want to modulate very artificial situation during the test. They don't really go from real life scenarios and real life files they actually receive every day, but they rather try to switch on an internal engineer and develop super APT they believe would attack them at some day. The problem here is that, again, they are not targeting the original goal, which was to basically block what's not blocked by AV and anti-spam. They model different attacks, and the actual results of it, of course, highly depends on the professionalism of the specific engineer. But just as I said, yes, it is possible to design an APT-like attack that will bypass any sandbox. That's the truth. There are no sandboxes that couldn't be bypassed by artificially created test that is designed with access to those sandbox. So that's, and so the main point here is, again, remember your original problem you want to solve with Sandbox, and rather than developing APT-like attack internally, think of actual files you receive every day, the files you've seen in the last week in the. And another source, by the way, another source of good files might be a retrospective mails and letters your users actually received during like last 1 week, 2 weeks, 3 weeks. It's always good to upload these files, if possible, to the Sandbox if you deploy it to the trial. If possible, it might be a good source of data because you will not wait the time in real life. You will just upload the letters that already are in your users' inboxes. If possible, it's a good step to do. Another common problem, yes, it's all about expectations from the sandbox. The problem might actually have different like nature. Sometimes it's very psychological nature, but the problem here is that usually in many cases clients expect Sandbox to detect like everything. They believe that this is a new technology that has to do everything that wasn't possible before. And for instance, they could in their thoughts they could include for example, different social engineering attacks and spear phishing attacks that not actually use malicious code, but they use, for instance, fake portals so the user that is under attack would go there by the link and, for instance, enter their login and password from corporate account. Such cases really very tough if they are not if it's not phishing for a service like Gmail or similar, and if the cases are designed for a specific company, it's not what you really need to expect from Sandbox to detect them. No, it's not about Sandbox. Sandboxes analyze malicious code and find the attacks that couldn't find by antiviruses. So any malicious code, yes, it's about Sandbox, but links to phishing websites with some fake portal on it, no, it more refers to functionality of anti-spam from my point of view again. So what are general criteria of Sandbox testing or comparison you run in your company? There are like 3 layers of it. The layer number 1, it's about evading sandboxes, because many attacks and many attackers, they actually running their attacks, they face every day the problem of sandboxes, and their main goal here is just evade it, not allow run the malicious code within virtualized environment, for instance, or not allow to download a link to this specific sandbox. There are lots of tricks. They might do different things with file containers. They could encrypt payloads in different ways. They could play with file formats thoroughly, and I will give practical examples of all these cases we actually see in real life, and we really recommend including in real life test scenarios. Another layer of Sandbox comparison is basically quality of detection. So it's about the situation when the actual payload was actually available to the Sandbox, it was run on it, and here it comes. We need somehow to check whether a specific sandbox is good enough in actually detecting the threats after it's available for analysis or not. Another important thing is false positives. So that's why Nick noticed that we are talking today. We are talking about the case when the price of false positive is relatively high, and mostly the analyzed objects are benign, which is true about web traffic or email traffic. Why I'm saying this? Because if we talked about the sandbox designed to analyze mostly malicious files, this sandbox they are just operating in a completely different environment. The situation is dramatically different. For example, sandboxes we are running within Group IB, they have they use basically another technology to work with the mostly malicious files, to classify them better and so on. And the sandbox designed to work with mostly benign files, it's Polygon, and it operates in significantly different environment in these cases. So false positives is a problem, and test cases should involve some cases for false positives as well, in terms of quality of detection, because you could detect well, but if your false positive rank is high, it's always bad. And third layer of what I think should be evaluated between different products is basically completeness and practical
value examples.
Yeah. So I mean, how much details you see in the behavior reports? Are there internal artifacts available from this report? All these details, they are very important to the actual analyst working with the sandbox, so he could conclude and make on his own opinion about the object. Because the verdict coming from sandbox, it's a verdict that came from automatic system, right? And end user analysts actually work with it, and the report really has to answer lots of questions the analyst might have at this moment. And different interfaces and different products, they really have different quality of these reports, and I will later see you. Okay, we have a question from Pavel. Can Sandbox be integrated with web application to verify uploaded file? It's a question about integration. If we're talking about Polygon, it has a documented API, and it could be integrated with any application. We have a few clients that actually did this. One of them had and still have basically client's portal, and he received some applications in different file formats through this portal. So there was a problem of a new vector that could actually be used to attack the employees of this company. And thing is that it wasn't really under control, because the email was protected relatively well, but this web portal and this documentary application was designed this way that after the file was uploaded by end user, the employee would need to directly download this file and open it up in the application like Word or Adobe Reader. So it was a bad vector to attack that specific client, and what we did, we integrated Polygon with this application. Basically, the integration itself was done by the client himself, but we provided API for the Polygon, and it was integrated with the application, and those files were checked before they were available to the employees. Okay, so going to practical cases. The cases I will discuss at this point, they are very practical, and they are very much affordable to repeat by anybody. The main idea of this testing case sequence is that we pick up operating malicious file that is actually malicious, and it might be even detected by antiviruses. It's not a problem at this point, because what we actually want to test is how Sandbox work with different formats and how easily the analysis itself could be evaded, because there are lots of ways to evade even the analysis. So very simple case, which is supported by probably most of the vendors: password protected archive. You pick up that file that was easily detected by antivirus and by its behavior, and put in a password protected archive. And at this point, you will just email this file, new password protected archive, and put the password somewhere in the text of the letter. So what we are testing here is that Sandbox, or application that integrates Sandbox to the mail flow, actually has this functionality of extracting passwords that are noticed in different ways within the letter, because devil is always in the detail. Many vendors, and I have seen such products, they only extract passwords from the letters that have keyword like password inside that text. So if your email message like, hey, here's your invoice, password for it is 1, 2, 3, 4, 5, 6, 7, it will extract. But if you will not include the word password in the letter, this Sandbox will fail, and it wouldn't grab the actual password from the letter and wouldn't be able to decrypt this archive, and this case will bypass even the analysis stage. So it's always good to play around with different situations, real life situations, put actual password for the archive in different places. And another case is the situation when the password for the actual payload is included somewhere near the actual payload. So you don't put the password to the text of the letter, you put it to a separate file like password.txt, for instance. And to make it simpler, archive these two files again to the one file. So in this case, you have one file and there are two files, the actual payload encrypted one and a file called password.txt. And again, it's an interesting case because many vendors will fail on it, and they wouldn't extract the actual password from this password.txt, and but the end user most likely would be able to do this. And the truth is that people, they like challenges, and if it's difficult to open a malicious file, they would work thoroughly hardly to achieve this goal, and they will open the malicious file. And it's sometimes I even think that the harder it is to open a malicious file, the more users actually do this. So yeah, specifically if it's delivered in a situation with social engineering, thoroughly prepared attack that actually originating from someone this employee knows, for instance, at least the name itself in the from field, it's something the end user know, the actual person that is known by the attacked user. He will pay his time and he will do everything is necessary to open this malicious file usually. Another case, and by case I mean not just one situation, but like a family of situations. It's a link in the document. You could start with very simple links like you could see on the screen. The simplicity of this link in terms of sandboxes is that it is obviously needs to be analyzed, right? And I'm not meaning here word malware in the file name. I mean the structure of the link. You could see that it ends with .jar, right? So it says to the sandbox that this is a file of potential malicious format, and there is no problem with downloading this link because it's not a link that should be excluded from analysis like links that actually change their state. And because links analysis is a very complex problem to the sandboxes. It is a fully automated systems, and sandboxes have to analyze as much links as they could, but there is a problem. They couldn't analyze all the links they made in the email flow because there are lots of links that actually do something. So when end user clicks on it, they unsubscribe him from newsletter or confirm some important action. For instance, I don't know, money withdrawal from Bitcoin website or whatever. There are lots of such cases and lots of links that are not that are not really should be clicked on it. So for a sandbox, it's a big problem because on one hand, Sandbox has to download lots of links, and more links Sandbox analyzes better. And on another hand, many links really shouldn't be downloaded, and That's why I'm saying that the link of the screen is quite simple, because there are no doubts with this. It has to be analyzed, and it ends up with something .jar, so it might be a malicious Java application, and it has to be analyzed. And actually, it's a good idea to test this link. Yeah, you could put it to a letter text. You could put it, and this is more interesting, you could put it to different file formats. You could put it to TXT file, RTF file, doc file, any Office file you could imagine. Put it there, because your end user would probably open this file, see the link, and in many cases click on it, because in many real life scenarios we see every day, it is obfuscated and again masked as a social engineering attack. For instance, end user open doc file and see something very similar to invoice, but the quality of the picture is quite bad to read and see what's there. So, and it's written there, click to download the actual invoice. Many folks, they really want to know what's there, and they click there. And another problem is that many sandboxes, they do not they didn't implement the functionality of parsing different file formats and extracting those links from objects. And it's again the point when one vendor could fail and another vendors could pass this test. And it's a good sequence of tests, because it's very real life scenario used by criminals every day. So probably many of you have seen it many times. Another test case is when rather than including link to the document, the file is basically included to the file. Is many file formats, they provide this functionality, and in this case, the original file, for example, PDF or doc file, it works as a container, and the original payload is built in to this file. And again, the user is involved in some kind of social engineering scenario in which he is asked to extract this malicious object from the file and launch it. So in many cases, this situation isn't supported by sandboxing vendors thoroughly, and you could find ways when the attacker could construct a specific PDF, ODT, doc file that have a built-in payload on it, and this payload is actually available to the end user, but Sandbox doesn't extract it and analyze properly. So it's a good test case. Going back to links, it's good to check whether a specific product actually support shortened links, right? Very simple idea. You just pick up this malware jar link and make it look like bit.ly/something, and after this, neither Sandbox nor end user could actually say what's behind this link, and it's a problem because there could be anything. So we believe that Sandbox has to support such a situation as well. Again, considering the situation of links that change their behavior. And another problem, links that requires user action. And at this point, I would say that almost every Sandbox would fail on this test. The truth is that if you construct a link that requires a user action that is very complex and sometimes not very complex, it will be a huge problem for Sandbox in terms of real life automatic analysis, because okay, we could open a link, we could open even in a full browser stack with JavaScript support and so on, so we will emulate the user. But if what if it requires entering captcha on it, for instance? What should we do? And captchas, they could be very different. Okay, yes, we technically could, and there are lots of technologies, we could recognize the captcha. If it's not good enough, it's always like a comparison between two algorithms, that one of the algorithms actually generates this captcha images, and another tries to recognize what's written there. But again, it's a huge problem, and think of lots of problems that we see here again in terms of automatic analysis. In the mail flow, there are lots of links, and if we analyze in links not only the first layer of I mean, the web, it's like tree, right? When you go to one website, on the page of it, there might be 100 of links to different portals. And performing this automatic analysis, you don't have enough resources to go all through this tree, right? It's impossible. But the end user probably have, because the end user could have, again, like could be involved in social engineering scenario, and he will be directed by something in the letter, for instance, to actually go through the links sequence and download the file. And for the Sandbox, it will be a huge problem, and such mail, I believe, will bypass all the sandboxes and will be delivered to the end user. At this point, however, it's important that sandboxes still have lots of options to detect such activity. And because after the original mail was delivered to the inbox, if the end user go through this scenario prepared by attacker and download the malicious file, it could be extracted from the web traffic, right? If the user download the file from the corporate network, it has to be extracted from the channel layer and analyzed there. So yeah, what you could expect here is that it has to be extracted while being downloaded by end user, but you shouldn't expect it. You shouldn't expect that Sandbox will detect it and block such message while analyzing the original letter. And the problem that comes up here is all these integration problems about SSL, for instance, right? The malicious file could be uploaded to even legitimate portal like Dropbox or Google Drive or whatever. And in this case, the file will be transmitted over your corporate network in SSL. And this SSL itself is super legitimate. It's SSL connection with Google. And you see the problem. Many of the companies, yes, they put and they basically attack SSL connections that happens in the network by specific products designed for this purpose. But many of the companies don't. So you see how complex the problem. Another case, and again, it's not a one case, but like a huge family of test cases. It's a slips, a problem about time. Imagine that the file just slips for a 20-second long loop before actually executing its malicious part. So what should be done here? You could test different approaches and different vendors if you want. You could construct such application that basically emulates this malicious activity, and you will check that, and you will see that different vendors have really different approaches here, because the thing is that even sleeps could be implemented in different ways. If you just sleep inside your code, it's one approach, or the malicious application could just wait a specific system time before it runs, or a malicious application don't wait a specific time, but it rather execute a long going cycle that calculates something and trying to, for instance, it's brute forcing the key to its own payload, right? So imagine we have like a cryptor that basically, while loading and after the application starts its execution, the first like 10 minutes it tries to decrypt the actual payload, and there is no actual password inside. The password is trying to be brute forced during this first 10 minutes loop. It will be a huge problem for sandboxes, because sandboxes have very limited time for analysis, because there are lots of files, and probably it's a good way to evade fully, at least full behavior analysis. For instance, our product in such cases, we will alert on this file saying that it really looks strange and it does strange things, but the rank of the alert will be very moderate, because at this point we couldn't conclude technically that whether it's malicious or not. It's just very strange behavior, and Polygon would say that it's something strange here. And the truth is that the number of such files in the real life scenarios is very low. Legitimate applications are not designed this way, so it's a good thing to check. Another very huge family of techniques that are used to bypass sandboxes. All these techniques are based by checking the environment, because basically the guest machines, virtual machines that are used to analyze files in sandboxes, it's a virtual machines, and there are lots of different indicators that could be detected by the malware. It's all started with simple things like CPU ID, MAC addresses of network interfaces, hardware configuration, user names, history of open files, history in system browser, and so on. Right? It's simple things, because think of your own browser, right? You have history there, and your username usually something human readable, and you have nowadays at least like 8 gigabytes of RAM on your computer, and probably like 4 CPUs. And in many sandbox solutions, the environment is dramatically different. They have like 256 megabytes Windows XP, 1 CPU, no browser history, no open files history in Microsoft Word, and so on. And all this environment is a huge sign to malware that the environment isn't something interesting to them, because nowadays there are very few computers that have such low amount of memory, right? And it definitely doesn't look like enterprise level workstation. So even this simple check, like check the amount of physical memory on the computer, it in many cases may bypass lots of sandboxes that are on the market. Go into the layer of quality of detection, I should say that it's a very complex thing, and it's very difficult to actually test it well. Because at this point, probably you could trust vendors with this, because every vendor has built internal infrastructure for such tests, and vendors really pays lots of attention to these questions. And every vendor has fully automated testing to cover those cases. And however, many people, they want to go deeper and perform their own checks on this as well. And again, in this case, you could try to develop your own application that is not known to antiviruses at this point, because it was just created. And what you should and or could include there. You could include there various methods of persisting on the operating system, injecting code into third-party processes, integrating with network, like sending data or downloading files and executing them. All this spying functionality, like creating screenshots and sending them to the network somewhere, to the internet. All these things could be implemented in such a test. And yes, you're right, it should be detected by its behavior, by a good sandbox, if the sample actually runs there. If you have enough time and willingness to perform this, it's highly appreciated to perform. However, I could give you some general recommendations that doesn't require any time from your side at all. For instance, you could pitch vendors against each other. I've seen it once with a trial we performed at a bank, and that bank basically said that, okay, we don't have enough time to create our own cases. There are 3 vendors on the test. We allow each vendor provide 10 interesting files to the test, contribute 10 interesting files to the test. These files shouldn't be detected by antivirus at the moment of the test. And basically, by doing this, they grabbed a good set of malware, interesting one, and every vendor was in this similar situation. They couldn't, even if they included all the 10 files were designed for the sandbox, they wouldn't get more than 10 out of 30, right? Which isn't good. So, and of course, every vendor was specifically asked not to provide samples that are designed to be detected by only their sandbox. It should be like real life scenarios. So in this case, from my point of view, it was practically, it gave very practical results to the bank, and they didn't like pay a lot of time to this, right? So it was relatively easy to achieve, and the result was good, because vendors provided interesting samples that they believe something important to detect. Again, it couldn't be detected by antivirus at the moment of the test, so it was at least reflecting this original problem. So going to the layer describing the content of reports, and by reports I mean behavior reports that are basically describing the malicious behavior of the analyzed object with a malicious verdict. What you could check and what you could try to notice within different vendors' reports. The number one thing is a clear description of malicious, basically clear description of what the verdict is based on. It should be written directly, whether a specific verdict based on static analysis, which is basically antiviruses, or it's based on behavior analysis. So the description of detected malicious patterns of behavior should be available on the report 100%. They should be written in human readable language, that what actually this sample does. If it injects its code to another processes, it should be written there, and there has to be all the details about this behavior, what code to which process, maybe dump of that code that was injected. All these things has to be available on the report. The report has to provide access to analysis artifacts like all dropped files, memory buffers, network traffic dump, and so on. Because while analyzing the report, the analyst really sometimes have to understand what this malicious file actually does, and he sometimes is asked to perform some kind of reverse engineering and understanding the functionality. And at this point, it's very good if the Sandbox provide very detailed reports that basically done this reverse engineering in behavioral terms, I mean, by himself. So at this point, he could go through these artifacts like memory buffers, dropped files, and so on, without even reverse engineering the original file. So with 0 minutes spent on it, it's good. Also, good reports has to provide all the indicators from the report for future possible enrichment and retrospective checks on the network and infrastructure. Imagine that you have an interesting alert with APT like Trojan that was sent to your company and wanted to infect your employees. It's good idea, always good idea, to check all the indicators of the attack in your environment. Maybe it's not the first attempt. Maybe something happened before that, and you will find IP addresses on your proxy logs, or you will find different dropped files on your machines that were attacked previously. It's always good to check those indicators manually, or which is preferably automatically if possible and you have such infrastructure. Attribution of indicators should be at least the accuracy of the attribution for indicators should be like process level. I mean, all the indicators you see in the report should be attributed to specific processes. So you would really easy differentiate legitimate indicators from malicious ones. Because the common problem here is that usually indicators from network or files in the report, they are sometimes a little bit mixed, legitimate ones with malicious. So it's good when all the indicators are attributed well, and you could definitely say what reflects the actual attack and what is done by the system itself. Another thing which isn't really important, but which could be helpful in many cases, is good if the report provides you screenshots and better video of actual screen of this virtual machine after the sample was launched or opened. In many cases, it really helps to differentiate false positives from really malicious objects. And in some cases, it provides you just good screenshots you could share with colleagues, like in terms of WannaCry attack, for instance, right? You remember that after the Trojan was launched, the screen itself of the attacked computer was dramatically changed and interesting picture appeared. So if your Sandbox provide this functionality with just one click, you have access to these interesting pictures and you could show to your colleagues and Twitter them, which is fun because otherwise you really has to run this malicious object somewhere manually, which isn't good. You could see, I blocked this this WannaCry sample. Here you could see how it looks like. If your desktop looks like that, you got infected. Oh, okay, so basically that's it about testing sandboxes. At this point, I wanted to go to deployment best practices. Because while integrating sandboxes to real life infrastructure, there are lots of questions appear, and we'll just spend 3 to 5 minutes to discuss the good practices to integrating such products. So imagine we have a mail flow which starts with MX servers from the left. So the mail coming from the internet would be first hit these MX servers. Then usually it's good to put anti-spam and multi-vendor AV check. There are lots of commercial products to do this, and of course you could build it based on open source if you have enough engineering skills within your company. Why should you put Sandbox after anti-spam and after AV checks? Because you want, at this point, you want to achieve two things. You want to decrease actual load that comes on Sandbox. So the less letters achieve Sandbox is better, because you will need to buy cheaper appliance basically, and you will have more performance for your peaks and so on. So it's always good to cut out all the garbage before Sandbox, because Sandbox analysis in terms of money, it's expensive, and if you want to analyze all the garbage, it will just hit your pocket. So it's good to cut out all the garbage from the mail on the first stage with the relatively cheap solutions for anti-spam and AV checks. And it's good if your AV system supports multi-vendor approach, because you know that all the vendors, they have different processes, they are represented in different regions and so on. So it's good to check the mail and everything with a multi-vendor approach. It basically makes the whole process more effective. So after this stage is done, it's good to route all your mail to Sandbox, and after being checked on the Sandbox with a delay for behavior analysis, the letters will be delivered to end user server, client access server, which is shown on the diagram here. Another approach is very similar, but there are two vendors on the infrastructure. One vendor is deployed inline with mail, so it actually blocks malicious mail, and another vendor is operating on the copy of mail traffic, analyzing what happens there. So at this point, you could easily compare the alerts provided by vendor number 1 and vendor number 2 and see which was better in which cases. And after evaluating the products this way, you will see even after 1 or 2 months of such evaluation, you will see that every vendor misses something, and every vendor detects lots of threats. So you will see at least that their alerts are different, and you will understand that vendor number 2 was deployed for reason. I mean, you 100% you will find cases that were missed by vendor number 1, and these cases, they might be something interesting. In some cases, it might be something not interesting, but that was missed by AV check. Anyway, 2 vendors deployed on the system, it increases protection. And again, multi-vendor approach is good either in antivirus products and sandboxes as well. Regarding to problem of web traffic analysis and specifically SSL traffic, I would say it's always good to have a sandbox deployed to either span traffic, basically raw traffic from your network equipment, mirror it to a specific port, and sandbox grabs this traffic and reconstructs all the connections, flows, and extracts objects to be analyzed from it. And another integration that is good idea to actually perform is integrating with a proxy with ICAP protocol. ICAP protocol, yes, it is a bit obsolete at this moment, but it provides lots of functionality. And if your corporate proxy is not Squid open source proxy, but something commercial, 100% your commercial proxy supports SSL decryption, and it has functionality of copying all this decrypted HTTP traffic over ICAP to the sandbox. It's a good idea to run this integration and receive all the decrypted HTTPS traffic. And ICAP here is just a simple way to achieve that, because you didn't really need to deploy anything new to your system. If the proxy is already operating in your network, all you usually need is to buy a new license for this functionality, SSL decryption. I mean, usually it's not that the cost itself usually is not very high, so it's a good idea to do if your proxy supports it. In this case, Sandbox will just extract and download and analyze more files, not only that were downloaded by plain text protocols, but also that were downloaded inside SSL tunnels as well. So our presentation before that was more about different approaches and different integration questions. At this point, as I represent Sandbox vendor Group IB, I will have your attention for 2 slides about our products. So the product called TDS, it actually has 2 different modules called Sensor. You could see on this screen. Sensor performs all the integrations within your network. It integrates with span traffic, with mail flows, with ICAP, and so on. So Sensor performs all the integration questions. And also itself, Sensor performs signature-based analysis to the network traffic flows. Group IB creates its own signatures, and Group IB is a vendor that has vast experience in analyzing threats and has a running forensic lab in the region. So our signatures deployed to the Sensor, they are really based on real life cases and scenarios we actually see while investigating and analyzing threats we face. Another module of the TDS family is Polygon, which is basically our Sandbox. And Sandbox integrates very thoroughly with a sensor. So Polygon, however, is abstracted from the original file sources. It does not integrate with mail or network channel directly. It operates, the integration operates using API between sensor and Polygon. And just as I said before, the Polygon API is documented and open to the Polygon users, and all users are free to integrate Polygon with some not standard task. For instance, I gave you about this client's portal. It's a good example of such task for Polygon. Any application that deals with files or links could integrate with Polygon and analyze those objects in our sandbox. So going to basically our architecture of deployment, it's very schematic. It doesn't pretend to be like technically accurate, but in general, it provides a good picture. So the sensor is deployed on the network, and it integrates with network equipment, and it integrates with Polygon directly, providing to the Polygon files to be analyzed and receiving reports back. Also, we have a running SOC within Group IB, which is basically web, which is a cloud infrastructure and related cloud services performed by Group IB CERT for analyzing threats that were detected by TDS product. So in this case, we actually run our business kind of MSSP. So we manage all this installation. We analyze events that were detected by our products, and we could perform a full cycle of incident response and even investigation of the cases that were detected by our products. Probably Nick could add something at this point.
Yeah, absolutely. Thank you, Nikita, so much for your presentation today. I always learn something very interesting from you. So thank you so much. So as Nikita mentioned, Group IB obviously has our own IDS sensor called TDS and our own sandbox that we call Polygon, and we look forward to having some of the tests thrown at Polygon that you've learned today, and maybe you can use a different multi-vendor approach that I thought was very interesting that Nikita mentioned. So now let's actually break for question and answer for the end of today's presentation, and I think there's a few questions already, so we'll pull them up. How can we have the presentation? So certainly we'll send out the recording from today's presentation and also the slides so that you can review the techniques that Nikita mentioned on today's webinar. And for me myself, Nikita, I thought it was very interesting actually how I was thinking, how can we get these tools to throw out different sandboxes that you might be testing? I think having the vendors compete against the other sandboxes and actually save time for the client, it's a very interesting technique to use.
Yeah, it's a nice technique. As a vendor, I even liked it, because at the first point I was a little bit shocked. What we have to come up with test cases, basically not for us, because providing samples, we're actually sure that we at least detect them, right? We wouldn't contribute samples that are not detectable by our product, obviously. So we have to come up with something interesting and we think is not detectable by others. So
exactly, yeah, very level playing field, and certainly saves a lot of time on on the client side. How many, one of the other interesting things that I thought about today's webinar was the kind of second line of defense from a number of different companies. What percentage of clients today do you see using a second line of defense strategy?
Not very much, honestly.
Mm-hmm.
However, there are some clients, even for instance, in Russia, that actually deploys second sandbox to the enterprise. We have an open case with a Tinkoff bank that basically deployed our solution to the system, even though they already have installed another product for similar reason, for similar purpose. I'm 100% sure that it will develop, the market itself will develop very similarly to antivirus market. So multi-vendor approach within antivirus idea is very common nowadays. So usually mail is checked with different engines, different signature database. Similar things will happen with the sandbox market, I believe.
Yeah. Excellent. And if you're not lucky enough as a client to maybe have multiple vendors competing and throwing interesting evasion techniques at sandboxes, is there resources that you can go to get these different evasion techniques or tools outside of our presentation, maybe that you can download and use yourself to test the sandbox that you'd like to?
It's always a good idea to run Sandbox just on your real life files that actually comes to your company every day, day by day. Nowadays, for example, email vector is widely used by criminals to distribute everything, starting from ransomware to real different looking APTs. So from my point of view, it's for a good test, it's just enough to run Sandbox for 1 month on real life traffic, on real life mail flow, and you will see interesting results. 100% see. Also, it's a good idea to compare. Well, obviously, if the threat was detected by any technology in your infrastructure, you should refer to Sandbox and see whether it was detected or not. So it's a good idea to compare with the results originating from different systems.
Very, very interesting. Well, thank you again, Nikita, for all your time and knowledge. A very useful session for, I think, everyone on the line, and I hope you all had the opportunity to learn something interesting. If you didn't know, Group IB actually hosts an annual conference in Moscow. Last year we had about 1,000 people visiting the conference. This year we expect more, and we've actually devoted 2 days to this conference. So if you'd like to come and meet some of Group IB's representatives and speak to Nikita, perhaps, and certainly you can see him speak on October 9th or 10th. So thank you everyone for joining today's webinar. We'll make the recording and slides available to everyone, so you have the techniques and do's and don'ts for testing different sandboxes. And certainly you can contact both myself or Nikita if you have questions or would like to learn more about Group IB. So thank you, Nikita, once again.
Thank you, Nick.
And thank you everyone for joining today's session.